Welcome back. Let's now look at the two example programs we saw in the slides. First one is the one that has a main function which calls a function called cube by value. Now this is the exact same code again. I'm going to run it first and show you that the output is actually what, there you go. Original value of number is 5, the new value of number is 125. So that's the same output that we saw described in the slides. Now, before I move on to the second example, let me set a breakpoint over here. Actually, let me move that down over here. And let me step through this program. So I'm going to hit F5 and I'm now at the first printf statement. There you go. And I'm going to walk through this. So F10, execute the printf statement. The original value of number is 5. So this is printed out right now. And now I want to step into the cube by value function. Now take a look. The value of number is currently 5. I'm going to step into this using F11 and take a look at the call stack. I'm now out of the main function and inside the cube by value function. And you can see that n of the cube by value function, the function argument, has been initialized with n equal to 5. And let me step. So we're now at the return statement. Haven't executed it yet. At this point, let me also show you something else. So right now I am in the cube by value function. But if I want to see what's on the stack, what the variables are in the stack frame of the main function that is right underneath it over here. If I double click on the main function, I can see the value of number stored as 5. So let me go back to the stack frame of the cube by value function. And we're back to the cube by value function. We're seeing the value of n. And so we're on this line 22 with the return statement. I'm going to hit F11. And F11 once again, that should take us back to the main function. Okay, there you go. So look at the call stack. Cube by value function has been, its frame has been popped from here. We're back in the main function. And numbers value is still 5. While the value returned from the cube by value function can also be seen here is 125. But at this step, the value returned by the cube by value function has not been assigned to number yet. So we are seeing both 5 and 125 displayed in the watch window. Now I'm going to hit F10. That will execute this assignment statement and number will become 125. There you go. Number just changed to 125. And now we're at the last printf statement, F10. Look at the output. So both printf statements have executed. Original value of number is 5. The new value of number is 125. And that's it. Remove the breakpoint. And I'm going to switch over to now the other example in which we pass by reference. Here you go. All right. So let me first run it as it is. The output looks the same. The original value of number is 5. The new value of number is 125. So as expected. Now let me do the same thing we did for the other program. Let me set a breakpoint here on the first printf statement. and run this. Okay, so we are in the main function. Let me run a step through this at F10. So we have executed the first printf statement. The original value of number is 5. Okay. Take a look here in the watch window. The value of number is 5. Ampersand number, so the address of number, is displayed right over here. And the value stored at that address is 5. We can see that, we can see that both ways. Okay. Now we are on line 15. Cube by reference is being called on this line. I'm going to step into that with F11. I'm inside cube by reference, and you can see that here on the call stack, the main functions stack frame has been pushed down, and on top we now have the stack frame for cube by reference. In the watch window, we can now see n pointer, which is the pointer variable integer pointer received here in the cube by reference function as an argument. Okay, the value stored at the location pointed at by n pointer is still 5. I'm hitting F10, so I'm on the line of code, still not executed. I haven't performed the computation yet. Here's the thing, I'm going to hit F10 and this is going to execute this line. So the cubing n pointer times n pointer times n pointer is now going to happen. Now check here, the indirected n pointer now shows a value of 125, meaning the value stored at location pointed at by n pointer, the value stored there is now 125. It's the same address that we have been seeing before. And let me jump to the main function and let's take a look at the value of the number variable in the main function at this time. We haven't gone back to the main function yet. We're still in cube by reference, but let's see if anything has changed back in main. Shocking. The value of number is 125, and that is so because changes made to the indirected value of n pointer at that location has changed when I made changes inside cube by reference. This is what passing arguments by reference is all about. This is communication happening from cube by reference function back to main function without using a return statement. And another thing to note, look at the address of number 00D3F918. That happens to be the same address that is stored in the n pointer 00D3F918. Alright, let's return to the main function. We're back. There's no assignment, nothing else needs to be done. There's no return value from cube by reference because the value of number has already been updated while we were inside the cube by reference function. So F10 to the second printf statement, execute that with another F10, and we're done. Here's the output that we expected to see. And one more F10 to finish execution. And that's all. That's a demo for performing the same function, performing the same task using a function that passes arguments by value, and then doing the same thing using a function that passes arguments by reference.